Hello and welcome to Mechanical Y. Let's say that I have a room full of people and I measure everyone's height. If this room is a random sampling of men in the United States, I know the average height would be 5 feet 9 inches. Some people in this room would be a little bit taller than this average and some people would be a little bit shorter. I, for instance, am 5 feet 11 inches tall. How would I compare to other people in this room? Am I unusually tall or am I close enough to average that I wouldn't really stand out? My brother, on the other hand, is 6 feet 7 inches tall. How does he compare to this room? We can calculate the absolute differences between our heights and the average, but looking at just the average and our deviation from the average doesn't give a whole lot of insight. In many cases, when sampling a group of similar things like people in a room, we get what is called a normal distribution, or a bell curve. This curve shows that people of a height close to the average are much more common, while the further your height gets from this average, the less common that height is. But how close is close, and when does the height become unusual or uncommon? To answer this, we turn to the concept of a standard deviation. Basically speaking, a standard deviation tells us how close a number is to the average. In this particular case, we have a range of heights of people in the room, and we want to know how close a particular height is to the average. The standard deviation of a sample set is calculated using a special mathematical equation, and the result is given in the units of the original data. So in the case of measuring people's heights in inches, the standard deviation itself would be in terms of inches. Measuring how far a value is from the average in terms of number of standard deviations will give us an idea of how common a particular value is. Specifically, about 68.3% of points will be within one standard deviation of the average. 95.5% will be within 2 standard deviations of the average, and 99.7% of data points should be within 3 standard deviations of the average. The reasons for these particular percentages has to do with the form of the mathematical equation, and this won't be covered here. If the standard deviation is a small value relative to the average, then the range of values is tight and there isn't much variation. If the standard deviation is large relative to the average, then the samples are spread out and there is a lot of variation. So going back to the height of people in a room, if the average height of men in the United States is about 69 inches, we can also look up that the standard deviation from this height is about 3 inches. This means that 68.3% of men in the United States are between 66 and 72 inches tall. I fall within this range, so I would appear to be fairly close to average height and would not stand out in this room. About 95.5% of men in the United States are between 63 and 75 inches tall, and about 99.7% of men are between 60 and 78 inches tall. Since my brother is 79 inches tall, which is about 3.33 standard deviations from the average, we can tell that his height is quite uncommon. Only about 1/20th of 1% of men in the United States are his height or taller. So in this particular example, I would likely not stand out in this room, but my brother would. Let's look at another example. I personally looked at a sample of 125 chocolate chip cookies, ordinary commercial grade off-the-shelf cookies. And without trying to eat the sample set, I measured the mass of each cookie and found that there was a distribution in masses. Some cookies were heavier than others. I can calculate the average size and standard deviation from this and use this in quality control. You see, because the company that produces these cookies wants them to be a consistent size. But variations in chip size, machinery used, and other factors means that not every cookie comes out exactly the same. As the producer, I can sample the actual cookies being produced, and in this particular case, I found that the smallest cookie sampled was 9.8 grams, and I found that the largest cookie sampled was 12.5 grams, and I found that the average mass of a cookie was 11.2 grams. I was able to calculate the standard deviation of this sample set to be 0.6 grams, which shows that this sample set is fairly tight and there's not much variation between cookies. I found that 99.7% of my cookies will be between 9.4 and 13 grams in mass. But if I take a random cookie and find that it is 15 grams, I know that this is unusually large and there is something wrong with my production process. And in doing so, I can help ensure that the customer receives a consistent product all the time. While it might seem like mathematical wizardry, calculating the standard deviation of a sample can give important information about a system. There are many useful real-world applications where determining how close a value is to an average is important. Well, thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, please visit us at our website, www.mechanical-y.com.